right, gang. Today we talked about natural versus artificial selection. So how do certain traits get passed down? Well, our warm-up was to explain the term survival of the fittest. Well, in class today, we explained that survival of the fittest, when talking about science, the fittest is the best adapted to the environment, not necessarily the strongest. Because remember, while The Rock is definitely stronger than Miss Humphreys, The Rock might not be a great life science teacher. Hopefully, Miss Humphreys would be a better life science teacher than The Rock. So it's not about the strongest, it's about the best adapted to the environment. So now we're looking at how did our traits get passed down? Well, there were two different ways. We talked about either nature decided or humans decided. Now, here was our first example of natural selection that we looked at, and we talked about giraffes. Now, not all giraffes started as these long necks. We talked today in class about how we started with kind of a midget mini horse, this fat little necked, like a horse-looking giraffe. Well, one of the biggest questions today is why didn't he just eat the bushes? Why did this tall giraffe have food and this lower giraffe didn't? Why wouldn't he just eat the bushes? Well, because everyone else is also eating the bushes. You have cows eating the grass, you have rabbits eating the grass, you have other life forms that are all on the same level, all competing for those same 5 bushes to eat. Now, the benefit of the long-necked giraffe is that he could reach those higher plants to get more food. He did not have to compete for the resources down here. So this giraffe had more food and he lived longer. Those short giraffes died of hunger because they couldn't get those resources. So the longer necked giraffes went on to live longer, and they also found a longer necked giraffe to mate with. And over generations and generations and generations, we ended up with all long-necked giraffes. This was not a one and done. It's not like this picture. We didn't have one short giraffe die and then all of a sudden they were all long neck. The short ones started dying off and the long neck started living. So as that happened, the population changed to long necks. Similar in our rabbits. We had so many questions about, well, what if the snow melted? Then absolutely, if we were in a brown mud grass, then that rabbit would be better. But using these pictures, we have a white rabbit on white snow. He is likely to live longer because he is camouflaged than our brown rabbit in the bright green grass. Absolutely, he can go find a tree, he can bury himself in the dirt, but isn't that more work? And you're more likely to be found by a predator who knows, hey, if I go look in that tree, I bet I can find a rabbit. These hawks are flying high above and cannot see the white rabbit in the white. So the white rabbits live longer, create more white rabbits, the population of white rabbits goes up. The last example we looked at today were our beetles. Immediately I can see these olive-looking beetles way faster than I can see these green ones. So this little lizardy is going to come eat those brown ones super easy. And again, the population of the brown or green, dark green beetles will go down and the lime green beetles will go up. So nature is deciding the trait that best allows that species to survive. Now, humans don't necessarily care about an animal's survival. We care about what they can do for us. So we are not breeding or mating animals for their survival. We're breeding them and mating them for what we want. So looking at chickens, back in 1957, you could get 900 grams of meat off of one chicken. That one chicken is likely to live for 8 to 10 years, have children, take up grain, but we only got 900 grams of protein out of them. Well, we took that chunky 900 grams and we mated it with another 900 grams. And that made a 1,000-gram chicken. Then we took that 1,000-gram chicken and mated it with a 900-gram chicken and made an 1,100-gram chicken. Again, it doesn't happen overnight. This is generations and generations that we have taken the fattest or the thickest of our chickens and made them make more children. I easily ended this line because I did not mate this chicken with anybody. So I mated these thick boys over and over and over until I got 4,300 grams of chicken out of one chicken. However, that chicken is not best suited for survival. It's likely to only live 2 years. It can't carry all that meat. It could be easily eaten by a predator because it can't run away. This is not the best for that chicken. It's the best for us. Same with dogs. All dogs started as wolves. That was our common ancestor. We domesticated them, aka made them our friend. And then we bred them for specific traits. We see in China, we had these sweet little floofy chihuahuas that made a little husky because it was colder in China. You look over in North America, where we are a little bit further down, and you see we have kind of a golden lab. If I needed a hunting dog, I needed to find a breed of dog that has good eyesight, can run quick, good smell. If I want just something cute and floofy to snuggle, I can just get a Chihuahua. But a Chihuahua would not make a very good hunting dog. So we look for the traits that we want, not the ones that are going to keep them alive, okay? And we don't just do this in animals, we do it in crops as well. So this is the graphic organizer we looked at today. And remember, a huge part of taking notes in class is that we do not write down every single little word. We write down the important stuff. So Ms. Humphries is going to go through and highlight what our important pieces are in this. So we're looking at natural selection versus artificial. Natural selection is without humans. Without humans. It increases the chance of survival, which we call survival of the fittest. And this happens in the wild. Artificial selection are selected by humans. They do not help survival. The traits that we keep do not help survival. And some examples are dogs, livestock, and crops. Now, remember in the middle of a circle, we have the things they have in common. Now, it doesn't matter who picked it, humans or nature. You still got those from your parents. We're still breeding a mom and a dad to make an offspring. No matter who picked the traits, you've still got them from your parents. And because this is sexual reproduction, we have a change in our genetics, or our genetic traits change. There is a change in our genetics. And as we've talked about multiple times, this occurs over many generations. It takes quite a while to happen. So if I am currently 4'6", I cannot just go find a 7-foot-tall mate and have 7-foot-tall children. My great-great-grandchildren might be pretty tall. And that is the end. That's all for natural versus artificial selection. That is everything, ladies and gentlemen.